to calculate the shade in the backyard and figure out how best to place the garden boxes in the back. The first thing we had to do was to assess the location, and that involved understanding the growing season, what times of the year we wanted to plant the garden, and when we could plant the garden, and then how many hours of light we would have per day to be able to grow with. What kind of light we were looking for depending upon the type of plants. Some plants, handle better afternoon sun. Some plants handle better morning sun. And then we had to determine, where the sun was going to be throughout the day. And that involved establishing where north was, and then the sun's path throughout the year, and then calculating how that affected shade. You can see in this picture here the shade on one of the south fences, and how that would affect, where we could plant the garden boxes. Obviously, the fences, the trees, they were obstacles that we need to take a look at to see, where the prime locations were and how many we could plant. So, moving on. First thing that we need to do is establish really the growing season. So, we need to find out when the last average frost date was, and I say it's an average because you never know for sure if it's going to freeze or not, but you can take the past and use that as a general guide, when to plant your garden. So here, this is just the Old Farmer's Almanac online, and I typed in Fort Worth. I'm near Fort Worth, and just trying to determine when the last spring frost and then the first fall frost was, to kind of determine when was our real growing season here in the Fort Worth area. And the dates were really from March 21st to November 14th. One thing worth keeping in mind here is that the average frost date, or the last spring frost, or however they define it, usually is not the true last frost. I mean, there may have been years where it actually froze after that. And so in this case, they said, taking the data between 1981 and 2020, that there's a 30% chance that it may still freeze or frost after these dates. So usually you kind of put a buffer in there of a couple weeks. This is where transplants come in to get you started before you have to put them out in the ground. But anyway, something worth considering is that just because it says last spring frost or first fall frost doesn't mean it might not come later or sooner. So how many hours of sun do we need? And that depends really on the plant. But most garden plants that produce something that's worth eating it's going to be about 6 hours of sun. So using that, I calculated, from 9 to 3 was probably a good buffer or a good average for the sunlight that we needed. The whole goal of trying to determine, how to calculate the shade that we'd experience throughout the year. So just using my trusty iPhone, figured out where north was, and then plotted that on a paper, a little bit like this. So taking the rough measurements of the backyard, I took that same phone to determine, the angles, or the directions of the house and the fences in the backyard, to really create a model so that I can plot how the sun rolls across the sky depending on the time of year and day, and use that to calculate, where the shade should be depending upon the heights of the obstacles. So we have the distance of the borders and the angles here, and I find making this to scale as closely as possible is helpful. So for me, that could be a ruler that determines, how many feet is an inch or whatever it is, but to scale really helps to really help in the process of visualizing what's going to be happening throughout the year. So the next thing we have to do is determine the sun's path. And I went to the NOAA's site here. You can see this. You can Google NOAA ESRL and find that without a problem. But on this particular page, it's really helpful. You can put in the city you're at, or you're near to, and then the month and day, and the time of the day, the year, and then you get these numbers on the bottom after you calculate the solar position that teach you about where the sun is at that particular time of day on that day of the year. And the most important numbers are solar azimuth and solar elevation. And the rest of them aren't really that critical for what we're trying to calculate today. But let's talk a little bit about what those two things are. So solar azimuth that really is, if you look at a compass, that same compass we used to determine where north was or where the directions of the walls of the house as we plot that on the map, this really is using, north and then counting clockwise from north around to point at where the sun will be. And so in the morning, it's obviously going to be off towards the east. And depending on the time of year, it might be closer to 90 degrees or farther away, depending upon, how late in the year it is and where the Earth is rotating to. So just keep that in mind as we will use this as we draw out the map. And in this particular case, 110 degrees was one of the numbers I had come up with from this solar calculator. And so if this is north, then the 110 degrees is clockwise around, and that's pointing towards where the sun is at that particular day and time on that day. So you might be asking, well, what about how high it is it in the sky? And this doesn't really tell me where it is. You're right. This just tells us the direction the sun is at. The next one, which is solar elevation, that's what teaches us really how high this is in the sky. And so using the direction plus the elevation really gives us a location of the sun on this particular day and time that we pulled off from the solar calculator. And this is what we're going to use to determine the shadow, the shadow length at the time and day of the year. So we'll use both of those. Obviously, the azimuth tells us where that sun's coming from, and the shadow will be the opposite direction of where that sun is coming from. That's worth keeping that in mind. Okay, so it's time to calculate. So it's time to calculate, and I used that solar page to take a few samples, using my estimated growing season. And I used, April 1st. I used April 24th just for a day to kind of see where the sun would be and how it changed depending upon the time of day and the date between those 24 days. And then October 1st. It said obviously that the freeze was November, but just to give me a good buffer, I used October 1st to get a good idea of where the worst case shade might be. So taking the azimuth and elevation for each case, you can see I have the date and then the time and then the azimuth from the solar calculator and the elevation from the solar calculator. And then I have to convert that, because we're using Excel or a spreadsheet in this particular model, I have to convert that into radians. I have to convert the elevation, which is in degrees, into radians, which isn't that hard. You just use basically the radian function in the box. You plug in the degrees and it converts it to this for you. And after we have that, then we can now use a trigonometric function of either sine, cosine, or tangent. And in this case, because we know the degrees from the ground to the sun, and we know the obstacle height, we typically use tangent. So what I did is I take basically the obstacle height and dividing that by the tangent in radians, and that gives us the shadow length. So you can see here on the 24th, the shadow length was 4.9 feet with an obstacle height of about 6.5 feet. And we can see that that shadow length is coming from an azimuth of 119, which is off to the southeast, which makes sense because it's the morning time and the sun's coming from that area, which means that the shadow will be opposite of that direction. It will be the shadow will be off to the northwest. And so we can plot that on our map of our house. Same for the rest of the cases here. Apply the same thing, and we get some different measurements depending upon October 1st is 8.7 feet, and then we can use that to kind of calculate how close our plots can be to the fence. All right, so once we calculate the fence, then we calculate the south tree. Same type of deal. We just put in the obstacle height, which is now I estimated at 30 feet. And then using the same azimuth and elevation degrees, I calculate what the shadow length should be. And then on top of that, knowing that because of the location of the south tree, those azimuths, the morning and the late evening or afternoon sun direction, won't really affect where I am because this is on the south. And so I went and got some samples from like noon. You can see that here at 2 p.m. at noon, on October 1st to get a better idea of where that shadow would be when the sun was actually to the south, and therefore the shadow was to the north, shading the yard. So we did that there and calculated a shadow length of roughly 16 to 20 feet depending upon the time of day. You see April 1st at noon, it was really a 16-foot shadow coming from the south to the north, and that would be a direct impact on the actual garden. Okay, so then we had calculated the house. I color coded this particular Excel model just to kind of show you which ones are applicable. And as you look at this, you'll notice that some of these aren't applicable just because the azimuth or the direction of the sun just doesn't affect us. But we still have an idea of what the shadow length is. That's not changing. It's just the shadow's not in the direction that affects us. And so using the house height of 20-25 feet, we were able to determine, a shadow length of 18.5 feet, 30 and 33 feet that could affect the garden area. So as you see here, I plotted all these different shadows. You see the house here at kind of the angle at 18 to really 30 feet. You can see the fence line along the west side at 46 feet of shadow, which really tells me the closest I can put my garden boxes to the fence is really about 4 feet, maybe a little bit more than that in order to have confidence that we have enough sunshine to grow a good crop. And then to the south, there's that large 30-foot tree that's going to put off shade to the south, to the north at about 16 to 20 feet. And that really bounds our garden area, gives us a better idea. And that's pretty much it. Thanks for tuning in today.